Hello. Hello, sir. Okay. Good evening, sir.
Good evening, Gautam. Is that Gautam or someone
Yes.
else?
No, sir. Myself, Gautam.
Yeah.
So, good evening, all participants. So, uh, today we have with us Gogandip, sir. Uh, sir, Gogandip, sir, is an IT professional with 30 plus years of experience in project management, IT consulting, software development, and corporate training. Proven track records in IT solutions, leading teams, and providing strategic consultancy. Expertise in network design, digital transformation, and training development. He is also the founder and director of Rosie Computec Services since 1995. He also the resource person like NITTR Chandigarh, AICTE, many FDPs. He also the IT consultant, technical advisor consultant, web application developer, corporate trainer, senior executive professor also in previously in University College, Kurukshetra University, taught various undergraduate and postgraduate courses in computer science from 2006 to 2015. And he also the author of 7 books on computer science, fundamental of computer, AI, DBMS, software engineering, and object-oriented programming, and also published 7 research papers on wireless networking, focusing on economic solution for wireless networks. He also the evaluator and judge in Government of India's events like Toykathon 2021 and Smart India Hackathon. So welcome, sir, in our FDP session. Sir, please, you can start your session.
Thank you, Dr. Gautam. Uh,
Thank you, sir.
Today, welcome everyone to today's FDP session under deep learning. Just I will. Am I audible and my presentation is visible to you, all of you?
Yes, sir, you are audible and visible also.
Okay, thank you. Thank you. Now I will start. Welcome everyone to today's FDP session under deep learning for computer vision. In this session, we generally talk about AI and deep learning. As you all know that deep learning is basically a subset of artificial intelligence that uses neural network to automatically learn patterns and make intelligent decisions from data. In this session, our focus is on that you don't need to write code to experience deep learning for AI or deep. We will use no-code AI platforms, especially Google Teachable Machine, to visualize how neural network learns from data. Let's start. Engineer Gautam already introduced me. I also tell you about me. We are also working on cybersecurity awareness campaign from last year. We are visiting at our schools and our previous schools, basically, from where we are alumnus, and also writing blogs at rogics.com. My site is rogics.com. You can see their blogs. Even this lectures blog is also written there, form of article, and you can visit. Also, we are working on cybersecurity. That for that we are making videos, YouTube videos for just awareness, and you can see that at Trozy Edutech. Fine. Now, before we begin, let's look at today's agenda. This session is designed to take you on a complete journey from concept to creation in no-code computer vision. We will start by understanding the idea of no-code AI and how it democratizes deep learning for everyone, even those without programming background. Those who are non-technical users, they also can use. Those who just know to use the Windows and all the stuff, but they are not technical users, they can use this Google Teachable Machine. That's why I took this as my topic, Google Teachable Machine. And from every field, from wherever, that is your art, from history, from science, from any field you are belongs to, you can work on this Google Teachable Machine, and very simply you can. Now, we will start from introduction to no-code AI, deep learning in computer vision, tools and techniques, Google Teachable Machine basics, hands-on demos. I will take 3 demos. One is image classification, general image classification, like is that cat or dog, or is that apple or banana? Fine. Or one is for health. That is for health, for basically medical patients. That is, we have elderly people in our home, and we want to check, we want to make surveillance on them, if they are fallen, they are right. We want to just surveillance them, they are okay. That's why we can use this type of project, Google Teachable Machine, in fall detection, also gesture recognition, model testing and deployment, what teachable machine can or can't do, ethical responsibilities, and so on. Let's proceed further. Now, as artificial intelligence once belonged only to programmers, we know that if you are a programmer, you can work on artificial intelligence, but with the help of this no code or low code programs, you can work on this type of artificial intelligence. Even on deep learning, you can experience deep learning with the help of no code programs. And for that, we will use no code AI platform, especially Google Teachable Machine, to visualize how a neural network learns from data. Now, you will often hear low code mentioned too. Low code basically where there is a need of a technical user, whether he is a programmer or not, but he must be a technical. He can write some short scripts or formula logics. For that, to make the control on the devices, or control on the program, what they are writing, what they are doing. For that, there is a low-code tools like Nine, Orange, Power Apps. These are different no-code tools we have, but today we only focus on no-code, not going to low-code. That's why we are using Google Teachable Machine. Even I'm not going on Edge Impulse, and Edge Impulse is also a very good tool. If you want to do work on like IoT and other devices, to control other devices, then there is a Edge Impulse. Must visit that tool and check that tool. is that good for you? Basically for IoT users, like you don't have devices and you want to do IoT, and with Edge Impulse, you can simulate everything with the help of Edge Impulse. Lobe AI is Microsoft project, and that is basically um, depreciated 3 years back. Now legacy they have, and you can get it from GitHub, and also that is able to do the things. Because no code, why we are focusing on no code zone? Because we want to make classroom integration. That's where maximum educational impact happens. That's why we are doing that. And educator, innovator, and non-coders. Fine. Next one is deep learning and computer vision. The connection. First one, there was a no code only. Now deep learning and computer vision, how they are connected. That is today's basically FDP theme, deep learning. Deep learning powers modern computer vision by enabling machines to automatically learn and recognize features like edges, shapes, and objects from raw images without manual programming. Sorry. For example, instead of coding rules through detect a cat, a deep learning model learns to identify it by analyzing thousands of labeled cat images, or detecting cracks in a bridge, or identifying a plant species. You can all do this with the help of no-code tools. It's all pattern learning, basically. What makes this session special is that we will see that learning process through a no-code tool, making deep learning transparent and experiential. And that's why machine learn to see patterns like we do. And for whether that is for medical image diagnosis, like fallen facial authentication, or traffic analytics, agriculture monitoring, these all are computer vision things, and we are working on that. Now we will move further. In computer vision field, there are many techniques and tools in computer vision. You all know that. Okay, I think from last 2 days, you learn about many techniques like image classification, object detection, image segmentation. Let's just talk about that. Basically, techniques are the AI tasks, what we want the machine to do. And tools are the no-code or low-code environment, or other even full-coded environment that helps us achieve those tasks without writing codes. Let's explore them by column. First is image classification. What is in the image? That is like, is that dog or cat or a person? This is the most basic and fundamental task. You give the model labeled example, say apple versus orange, cat versus dog, and it learns to classify new images. And tools like Teachable Machine and Microsoft Lobe AI make this as easy as uploading folders of images or capturing images. These are great for teaching supervised learning, because we know that image classification belongs to supervised learning concept. That is the main concept. After that is the object detection. Where is the object? What is it? That is, unlike classification, detection involves finding and labeling objects within an image. For example, detecting multiple tools on a workbench or car in a traffic field. And also you see that there is a bounded box there, from x1, x2 coordinate to y1, y2 coordinate, or 4 coordinates are there. It depends upon. That is lower corner, lower left, lower right, upper left or upper right, all these corners. That is the object detection. And for object detection, we also can use another no-code tool, RoboFlow Universe, MakeML, or V7 Lab. Why we are not using teachable machine here, just we will talk later on. And another one is image segmentation. Image segmentation is basically where we are talking about each pixel, like pixel by pixel, whether that is a road, sky, or vehicle, one step deeper, not just detecting where the object is, but outlining which pixel belongs to it. That is the main concept of this, and V7 drawing and super annotate work for that. Another one is face recognition and emotion detection. That is face recognition, who is in the image, like that is Gagan, like you want to make a attendance classroom and you need a tool, then teachable machine is not good tool for face recognition, but basic emotion detection it can do, because Google working on this, and they are just making, that is for image classification, gesture detection, and post estimation. Basically, there we have different gestures, like we are making a thumb impression, or we are making the pose estimation, yoga poses. Like our body have 17 points in our body, like ear, nose, left ear, right ear, mouth, all these points. With this point, our arms, our all these points, that is different things. And with this, you Google teachable machine make a postnet project. Basically, there is a post project known as a postnet, and where with that will do all the gesture detection. Now we will move further. And what Google teachable machine is, that is our main focus and our laboratory for today. It's a web-based AI training lab that runs entirely in your browser. You can create an image project, train a neural network visually, and deploy it in minutes. Technically, it uses mobile net as a base model and applies transfer learning on your uploaded data. How many people know about mobile net and transfer learning? That is two terms I used here. Let just I talk about that. Mobile net is a lightweight, efficient deep learning architecture created by Google, specially designed to run on this teachable machine and run on mobile devices, run on your browsers, run on your edge hardware like Raspberry Pi. Like edge hardwares are like you want to do some local, something you want to run on local machine, not on cloud or central server or anything else. Similarly, that is the edge hardware, Raspberry Pi. And mobile net is pre-trained on ImageNet. ImageNet basically a data set of over 1 million images from 1,000 categories. Dog, trees, building, and so on, fruits. So it already knows how to detect shapes, how to detect curves, textures, and colors in the images. After that is a transfer learning. Transfer learning I used here, and that is a very simple thing in day-to-day life. When you drive first time your bicycle, and you want to drive a two-wheeler like your scooter or motorcycle, that is very easy. Means you know about how to manage handle and how to drive your cycle. Similar devices are there are motors and that is without motor. That is the main difference. Like you learned car driving and you want to drive some like bus. You want to drive a bus or other device, car. Then the basic things are seen. That means you transferred your basic learning to other, and that's why you use that. Means reusing knowledge that a model has already learned from one task and applying it to a new related task. That is a general layers we make here and only retain the last few layers. Only retain. Means you have millions of layers, but you retain a last few layers, thousands of layers. Out of million layers, you retain the thousands of layers to transfer your learning and give your project a process. Let's see here. This is the training from scratch. Millions of weights are there. When there is a transfer learning, you have a pre-trained model that is just pre-trained model. You are retrained them. Like here in today's lecture in hands-on session, we are taking only 50 to 100 images, and with 50 to 100 images we can train our Google teachable machine, because that is a deep learning and different layers are there, and all these processes, all the layers are already learned by there, and you can only communicate, you retrain with some few layers. Fine. That means it fine tunes on the already smart model to recognize your specific classes, even if you only give 50 images per category. The magic here is simplicity. No installation, no coding, no backend, just your creativity. This makes it a perfect educational gateway into AI. Whether you teach computing science or art, anything you are teaching. And even I'm saying, okay, if we want to just introduce artificial intelligence to our first year BTech students or BSc students or BCA students, I think different faculties are here, and they can just use Google Teachable Machine. They will learn from this and make different projects, and you must be astonished how these people make a creativity to learn from Google Teachable Machine and to make a new projects in this area. They will find. That's why that is ideal for education and practice sessions. Now, when you upload your own data set, say images of apples, bananas, and orange, teachable machine does not train a new model from scratch. That is, instead it performs transfer learning on top of the pre-trained mobile net model. Here what happens technically? Simplified, that is, teachable machine loads the pre-trained mobile net models. It logs, freezes the earlier layers. They say as they are. It adds a new classification heads, a few dense, fully connected layers at the end. You can see here the same image I took from the last slide. I have a question. Just this retaining is fast because it's adjusting only a few thousand weights, not millions. Why? In Google Teachable Machine, retaining is fast because it uses transfer learning. It starts from a pre-trained model like a mobile net, which has already discussed in our previous slide. Right? Now, what Google Teachable Machine can do well? Image classification. Google Teachable Machine can do image classification because it is a wonderful educational tool, and it is intentionally simplified, focusing on ease of use, accessibility, and conceptual understanding. Let's look column by column. That is the image classification. It is a core strength. It uses a pre-trained convolutional neural network, CNN, that is mobile net, to identify images and patterns like color, shapes, and textures. Pose recognition works because TM connects to the PoseNet model. The PoseNet is basically our body's 17 key points that classify poses like sitting, standing, or raising hands. Now, I'm not going into the detail because I think we have to work on that teachable machine. And these all audio classification you can do. You can do cross-platform exports, run models on web, mobile, or edge devices. Instant testing and feedback, yes, that is also we can see in our hands-on session. Ideal for education and FDP awareness. We can even on hackathons. Limitations. Just see that why teachable machine can't do this. Like object detection. Teachable machine is not good for object detection because teachable machine can't locate where an object appears. It only compare patterns, curves, or shapes. That means only what it is. That's why we that is not easy to make object detection with teachable machine. Similarly, we can't do image segmentation because color and outline the region of interest, that is not working on that. Like tumor region in X-ray, that is not easy to make with the teachable machine because teachable machine is working for just awareness, and that is not want to take over on TensorFlow and other computer vision libraries. That's why they are just till they made only classification, pose detection, and audio. And they can't recognize individual identities or analyze emotion truly. Multi-class detection in one frame, that is not. Basic emotion analysis is there, but face recognition is not there because it can't identify individually. Someone from my some lecture, someone asked, can we make attendance system with this? No, you can't make attendance system with this teachable machine. You can only work with, you can count girls and boys. Yeah, how many girls are there? How many boys are there? That is, their patterns are different. That's why our system can recognize that patterns, and according to that pattern, they count how many people are there, how many boys and how many girls are there in the classroom, but not facial recognition. Limited export formats, yes. There is a limited, only TensorFlow JavaScript or TensorFlow Lite is there, and that we are working on. How does it work? First part is data collection. I am not boring you, just I am moving to teachable machine, and we are working on this teachable machine with google.com. Like data collection, either you can upload or capture sample images. Model training, simple. That is with the transfer learning on mobile net. And testing and evaluation, review results live via webcam or with the help of files. You can download files, whatever you want to do. You can make your website. Everything we will discuss today, and we will talk on this. Export, convert, and deploy on your website, your mobile, your edge devices. Let's check AICTE Teachable with Google.com. If you have question, you can ask me now. If you have any question, you can ask me. Otherwise, I am just by giving the example on teachable machine, you will understand everything. Even you can do yourself with me. There is no problem. That is a very simple. See here, train a computer to recognize your own images, sounds, and poses. Like this one is me and dog. Tree, wings, like pose net. Fine. These are 17 points which they are working on. Your voices, your speaking. You can, teachable machine is a web-based tool that makes creating machines. That is a very simple. Gather, train, and export. What can I use to teach it? Images, sound, and poses. Tutorial, there is no need to take a tutorial, just get started. I'm starting here with simple. Is this visible? Teachable machine is visible now?
Yes, sir.
Gautamji, yeah, teachable machine is visible now because we are working on this. Now, image project. There is an audio project and last one is pose project. First, we start with image. Basically, we are working on computer vision. We are just focused on image and pose, basically images. And also, we will talk about audio project in the last minute. Fine. First one is image project. See here, standard image model or embedding image model. Means if you want to work on your microcontrollers or your different IoT devices, you can use TF Lite for microcontrollers, TF Lite, that is embedded image models. But what hardware support these models, you can check. We will talk on standard image model, best for most users. See here, gather samples. There is a class 1 and there is class 2, and you can add number of classes if you want to. Fine. And gather samples like with the help of webcam or with the help of your upload files. I will start with webcam first, just webcam, and allow. I just given the just allow the video camera here, and we can communicate with this. Now we want to check. Just I will check my table. I have 3 mobiles here, and some pens are here. Fine. Just we will detect which one is pen and which one is our mobile. Just see this. Like class 1 is pen, and I want to record this. Just I took my all pens and I'm just out of the image. Otherwise, it will recognize. Even it will recognize the surface. That is also an image for this. And just click on hold record. This is pen, hold to record. Hold to record. You can even crop. Hold to record. Hold to record. I took number of pens here. Crop. I want just my hand is out of this box, and I will use and hold to record. How many samples I want to take? As much as I want. Fine. Done cropping and hold to record. We took 46 images. Fine. Here you can see that there is a 46 image samples. Class 2 is mobile phone. Mobile. This is now complete. Now take mobiles. I will record mobiles here. Crop. Fine. I will take some images of another mobile. Take images on various slides, various methods, and various intensity of light and different things. Just see, I took my fingers here and it will also recognize my fingers. Fine, now. Just I took some images and now train model. Simply just completed 85 images of phones and 46 images of my pen samples. Train model. This is going on training. It will take 1 or 2 minutes maximum. You can ask in between if you want to. If you have any question, if you are doing on working on this teachable machines, just you can ask. Okay, export your model if you want to. Just we will check first. Is this a mobile? See, their mobile is 100%. And now you can see that there is no object. Taking background as object. Also, if I am using my fingers, that fingers are used in mobile. That's why it is giving as a mobile. Now, I will take a pen that is 100% pen. See, 95%, 100%. It will say what object it is here. We took only 46 images and 85 images. That is the beautifulness of this tool, because it works on simple. Just give some images that take millions of images, that is with this, and work on transfer learning, because that is on mobile net. We have a different images in different layers, millions of layers, and that is the way. Now, you can export this model. There is an export model. Just see here. What this export model is, I will show you in our first project. In other projects, there is no need to show this. Just you can go there. Just see, upload shareable link, upload my model. That is on your system, always be on in your browser. There is no need to go to server or go to cloud, because we are saying that go to update my cloud model. That's why that is going on updated cloud model. That is going on this. Copy this and just paste here. But Google is not using these models. These are private models. And if you want to participate in this, you can. You can tick the participation box there, and that's why you just see here. Just see here. 10. Because if fingers are there, that is confused in mobile and pens. Fingers are there. Fingers I used in my mobile network. There are many times finger came. That's why. That is the preview of your model that is updated to Google server, and that is private for you. That is your teachable machine, and you made that project. That is not participated or distributed anywhere. Just if you have that model code, you can use that. Otherwise, that is also depreciated or deleted wherever, whenever they want. This is another. Now, that is the a simple model here. If you want to do JavaScript code, make your website, then how? First, we use updated cloud model. Now, see here, code snippet to use your model. Just here is the model. Copy this code. Simply come to notebook, new, paste here. Find file, save as somewhere like TM project. Like I want to this give as a index.html. Save. Yes, replace that one. That is saved in our drive. Just I will show you. I made a teachable machine project here. That is a teachable machine project here, and this is index. If we want to run an index file, we need a server, because that is not a simple index. Just you made a simple HTML file. There is a code. Different codes are there. There is a different JavaScript. And for JavaScript, you need a server, either NPM or Windows server or X server or Apache server, whatever there is required, you have to start that server. These are the steps, just I will show you. Just save that file anywhere. Check Python version, you have Python or not. If you have a Python, start Python with the Python server. And just see here. Come to the just link, and I will come to CMD. CMD command prompt is here. CMD is here. And in this CMD, I will use that server command is this one. We need a HTTP server to run that code. Python m http dot server. Python -m http dot server. Just run this. Server is on now. And what you have to do, you have to start localhost with the, just see here what localhost is there. That is 8000. Fine. Just start here. HTTP localhost 8080. Fine. Fine. Port is 8000. Just see there. I think some spelling mistake. In downloads, I have my project, TM project. And that TM project has, when I click on TM project, that starts. Just click on start. You will see that will get your permissions for camera. Allow that. And when you allowed, just it will start here. Just it will take time. And see there. Mobile. Pen, 100%. Fine, 99%, 100%, whatever is. Because it also take care of surroundings. What surroundings are there, which thing is able to see the camera. That is the way you can do your website. You can do with your if you want to do your IoT project, you can do with that edge devices.
Excuse me, sir.
Yes, sir. Yes, ma'am.
Sir, can you tell me on which ML model this teachable machine is made? Means what is the background of it? Which machine learning model it is using, or are we creating our own models? And which model is being built over here? There are so many ML models.
Yeah, there are so many models. Okay, I will explain you in this. Fine.
And
Just
can we generate the means accuracy of this model? Like you
yeah,
said,
yeah.
this 10 and
Accuracy is basically that is working on deep learning, and deep learning CNN models are there. I already told you the CNN model is there,
can we
and
generate the classification report like precision recall and what is the true positive and false positive over here?
100%, 100%.
How can you do that, sir? Can you show?
You want to make a report?
Whether the pen is, what is the accuracy of recognizing this pen or mobile phone? What is the precision or recall of this model? Performance parameters.
Performance parameter is 95 to 100%. Efficiency is 95 to 100%. You are just seeing here. We took only 25 to 100 images. I I will just wait. I will take another phone and recognize that is that phone or not.
Can
It is
I?
not just
Yeah.
taking care of these three phones and these five pens. It will take care of millions of pictures with that and taking care of everything.
So in
I
background, what
think
it is doing? I want to know what is the background of this teaching machine model.
I just explained you. Okay, that is working on mobile net transfer learning.
Okay, only one model it is working, or there are so many, because mobile net is only one model.
Mobile net is one model. Basically, they are working on CNN. CNN is a particular convolution neural network model, and we are working on that. When in deep learning, we are working on these models. There is another model, PostNet.
Okay, sir.
I am just confusing. Yes, you are using PostNet, you are using mobile net. That is a PostNet, you can say. For audio, there is another model. Just audio. Three models they are using: PostNet, mobile net, and another one is just slipped about audio model. Audio model is also there that can recognize every talk, every type of clapping, whistles, silence,
What about
anything.
VGG 16 and VGG 19 models?
Anji,
VGG 16, VGG 19 models.
I will explain you. Just wait for that.
Okay, sir.
We will complete this one or start on that.
You can complete, sir. You can continue.
Yeah, just I will complete, and after that I will explain you everything what you
Okay,
want.
sir.
I think
Okay.
just wait for 2 or 3 minutes. 2 or 3 minutes in 10 or 20 minutes. I think we have 1854 means 654. We will talk about it on 7:10. Fine, after 10 minutes, 10 or 15 minutes. Just after that, there is another model. Sorry, there is another type of machines which are working on. Another one, like in medical health, we want to check the image, someone is fallen or not fallen. We can check. We can even surveillance on hospitals, in our houses, for our elder people. For that, there is no need to just slip by or make, just upload the images. That next part I want to show you with the help of upload the images like this. I will start with the new project, teachable machine. Just close this. That is image project. Like I want to give upload images. Upload images like that is the that images. Images. This one is like we have different fallen images. Like here we took many fallen images. Control A, select all. Control C, and cancel. Just I will take 50 images of fallen people. Different fallen shows here, fallen. And another one we are using here, upload images, not fallen. Any sitting, standing, any type of images are there. Just 65 images of that not fallen images. Not fallen. Yes. Train model. Training is going on. Simultaneously, we will talk on this model. I told you, okay, they are using pre-trained model. In pre-trained model, I defined you. One is the mobile net, another is the POS net. These two models here we are using just these two models. Third one is basically that works on Yamaha systems. I think Yamaha, yes, you know about na Yamaha sound cards came there, and they are working on these audio systems. And from Yamaha, something model is they are using. That is the third model. And model trained, just see, not fallen. I am sitting here, not fallen. I am standing, not fallen. Fine. But when I go down, it will just show, okay, that is a fallen. There is that fallen or not fallen works. And even you can give images. There is no need to take all the images, visual images or live images. You can take file. Similarly, as you uploaded the images, I will take another images like this one, pollen, like this one. Not fallen, but it shows fallen. Why it shows fallen? Because in our images, see here, this image is on stairs and it looks like that. That's why it gives us, that is confused in between, that is the 100% means there is no efficiency because we have not given the number of images, only given the 50 images and 50 that images. That's why I took that image for you. Just see here. I am taking sitting another model, sorry, another image that is fallen or not fallen because that is in between. This type of categories, this type of efficiencies it will give. If we work it with PoseNet, is that working properly? Just check it. Just check it. Pose project. Upload. Fallen. Pose samples. Another one is not fallen. Upload files. Not fallen. Train model.
Hello, sir. Hello.
Hello.
Sir, you are not audible.
I'm not audible.
No, no, sir. Last say 1 or 2 minutes.
No, just I'm waiting for that. That is a trained model, na?
Okay, sir. Okay, sir.
That is getting trained. That's why I'm not audible.
Okay, sir.
Just see. Class one, we just whatever is fallen. And one is not fallen. There is a need of okay, that must be retrained. There is no need. Class one is fallen and class two is not fallen. Just see, that is on PostNet, and our 17 points are there. If I am going to down, just see this one. Actually, images, distance matters. Something, I think, some angle distances, yes, on sitting, on standing, it is saying okay, that is fallen or not fallen. Basically, efficiency is good, 85 to 95% or even 97, 98% is there. But sometimes depends upon the which model we are using, PostNet using or mobile net using, or these two models for these we are using here. For that is object detection or object classification. And another one is your gesture or body pose. Fine. That is the main concept here. And we can use all these models here. But now the question is, may I know your name, Miss?
Dr. Deepika, sir. Dr. Deepika.
Dr. Deepika.
Yes,
Dr.
sir.
Deepika, just I explain many things here. Just see.
Yes.
One, I explained that they are using CNN network and they are working on TensorFlow. Fine. Whether
Okay.
that is TensorFlow JavaScript, just think about my third or fourth slide. I think there I defined there is the TensorFlow JavaScript, and even you can see here in the export models, we are working on TensorFlow JavaScript, TensorFlow Lite. Fine.
Yes, sir.
They are working on this, and they all have a pre-trained model. But also for images, that is working on mobile net model, and next one for poses, that is a PostNet, mobile net or PostNet. And third one, I just forgetting name, that is from Yamaha, and some Yamaha net या Yamaha something कुछ उसका वो है. That is the audio for audio thing.
Okay.
And efficiency why changes, like I had given here images, and that is the basically depends upon your just I will close this. Any question? Just wait for this.
Sir, I'm Jagdish from Maricha University.
Jagdish, just wait for a minute. Just complete the answer the question of Deepika, and then we'll talk to you. Fine?
Yes, sir. Yes, sir. Yes, sir.
That depends upon basically accuracy of camera, accuracy of your full body visibility, depends upon lighting, clarity, consistent environment. It depends on, like we are managing this ImageNet model for mobile net model for our elder people, or PostNet model for our elder people. We will shoot them take pictures, images of them on different angles, different lighting, different luminosity or different things. And it will give our perfection 85 to 95% efficiency dega wo, 100% dega. That is the these models. Only they are using these three models. One is MobileNet, another one is यामा का क्या है यार, एक मिनट. I think these are the same things. Teachable. That is MobileNet. Inception, etc. is used here under the hood of each mode of teachable machine. That is a pre-trained model architecture. That is main. And working on the TensorFlow and TensorFlow Lite. Can we CNN networks? Fine, Deepika. Any other question?
Yes, sir, fine. And also the accuracy and other things can be done on the Python code itself. We can export the code.
That is dependent on the quality of your images.
Yes, sir, done. I got the answer.
That is, if you have 100 of images or 200 of images, but different lighting conditions, that changes.
Fine, sir.
Fine.
Thank you.
Okay, Deepika. Now, yes, please. Another question.
Sir, yes, sir. Good evening, sir.
Good evening.
Thank
May
you
I know
for
your name?
Jagdish.
Jagdish. Jagdish, boliye.
Yes, sir. Thank you for our session, sir. Really, it is very useful for us.
Thank you, Jagdish.
Sir, now my question is, for example, say we have 6 different persons.
Yeah.
Say I have their voice data with me.
Voice data.
Of 6 different persons.
Yeah.
Now I will upload these 6 different persons' voices into Google Teachable Machine. I will try and to find a classification. So which person is actually speaking by sending a speech sample.
Yes.
So now, sir, my question is now, can I deploy this exported model on any hardware?
Yes, you can.
I can do it in real time. So what is the process? Yes, sir.
Whatever is the export file, that is export.
Yes,
just see here, image model.
Yes, sir.
Just see here, export models.
Yes,
you
sir.
have 3 types of files: TensorFlow, TensorFlow JS, and TensorFlow Lite. That is for different edge devices. One is for MobileNet, one JavaScript is for your website. Lite, I think TensorFlow is for any other your edge device. Fine. And TensorFlow Lite is also for Android and other devices.
Yes, sir.
Mobile devices. You can just see here, click here, copy this post and open. Whether you are using P5JS, what is the requirement of your IoT device? It will cover TensorFlow.js give you JavaScript or P5.js. Fine. TensorFlow will give you Keras or OpenCV Keras. And I think in IoT devices, OpenCV is good, always be good.
OpenCV, sir.
है ना? But if you are using Kera, sorry, you want to make a IoT system for this, don't go for teachable machine.
Yes, sir.
Just go with image pulse.
Yes, sir. So if I deploy the model in the hardware, if I connect a microphone, so definitely if I ask any one person to speak on the microphone, in real time, will it classify?
Will respond approximately 80% in audio.
Yes, sir.
That goes 80%, yeah.
Because it gives on the output probabilities.
Yeah.
Yes, sir. But I never actually I'm trying for this, but not getting the proper source of information anywhere, sir.
There is no need.
Yes.
Just I am saying, go for image pulse.
Yes, sir.
That is a very good tool for IoT devices. You can simulate there. There is no need of IoT device.
Yes, sir.
After simulation, you can export that model to your IoT device.
Yes, sir. Sure, sir. Thank you, sir.
Welcome, Jagdish.
Thank you, sir. Thank you.
Welcome.
Sir, I have one question.
Deepika?
Sir, shall I proceed?
Yeah, who is this?
This is Dr. Meenakshi from Tamil Nadu.
Dr. Meenakshi. Yeah,
yes. Actually, we are training a model, no? So it may occupy a number of storage space and other things. Generally, what is the bottleneck we have is whenever we go for deep learning model, we need to have GPUs and other things so that high processing elements can only process this deep learning and other things.
Yes.
And whether any that is limit is there. That is training how many number of images, maximum limit is there. And one more question is, once we complete the training and other things, can I understand that this model is like a ready-made model where I can go for just testing purpose? I can integrate with my project so that I can do only testing work in my own system, where the training and other things it will be completed in some other remote machine. That is, it is done ready-made, and I'm going to integrate that ready-made model to my project. Is it so? Can I understand like that?
Just wait. Basically, this Meena, basically this teachable machine, not model, teachable machine made by Google is for educational purpose.
Okay.
And working on your edge devices. Mean local devices. Like in browser, I am doing this.
Okay.
And my system is of only 4 GB RAM, and actually, today is the very bad luck. Today in morning, my system crashed, on which I am working.
Okay.
And that's why I made this presentation and all things again from morning to this time. Right? Okay. And there is no need. Even on that system, I can say that is of 16 GB and GPU is there, and there is no GPU, 4 GB RAM, and working fine with 2 or 3 classes, 5 classes, 10 classes. Fine. Because that is working on your local device. Okay. And there is no CNN model we have to train. That is already trained models they have. We have to give only 50, 60, 100, thousands of images, nothing more than that. Okay. That's why there is no capacity barring there. Means there is no limitation of that type of thing. If you want to export that model and use that on your device or edge devices, that is also working with simple short files. Okay. Then I don't think so. I never tried, but I don't think so. There is a need of special machines or for teachable machines. Only
Okay.
teachable machine I am talking about. With Edge Impulse, you have another, just visit, just I am telling you there is another model, RoboFlow and Edge Impulse, and you like it, love it.
Okay. Okay. So this is just an AI tool where we can build our own deep learning network to train some small number of images and other things. Am I correct?
Yeah, because that is retraining. That
Ah.
that I will take you to the my first image I show you.
Mm.
Just see here. This is training from scratch. That is already done by Google.
Okay.
You are using retraining, transfer learning from, actually they know all things,
Mm.
shapes, curves, and all these things.
Okay.
Just you are training for your apple, your mangoes, your bananas, or your cat, dog, or fallen or not fallen, all
Okay.
this. Now clear?
Yes, sir. Understood, sir.
Just see this image, nothing else.
Okay. Okay. Okay, sir. Thank you. Thank you, sir.
Welcome, welcome. Anything else, please?
So, what is this RoboFlow you were saying? RoboFlow, and what are the name?
RoboFlow is also a no-code tool.
Used
No-code
for
tool. Just I'm taking to you another. I left my presentation. I just explain you everything. Just wrote here. I will send you all people. This is. I have one slide. I think I hide that slide. Yes. See this slide. See, these alternative tools are all no-code tools. RoboFlow, MakeML, Edge Impulse, V7 Labs, Super Annotate, CVAT, Clarified. These are paid tools, but giving you some free credits and easy to use. Edge Impulse is both type of model, that is open source and paid model. Nowadays, nothing is open source. Every open source gives you basic things, and after that, that is a paid. That's why you can use all these types of models, even YOLO V8 and Bayer or Overflow you can use. Fine. Actually, we don't have a time to go on RoboFlow and explain and everything, because we have we just have a 1.5 hour, and I explained you 3 types of things. Even audio model I left you. That is a very simple. Just I explained you all these things. There is first class, that is a noise, means environment noise that captures.
and
Other
sir, how
things
to
are same.
control the IoT devices using any model is there to control the IoT devices?
Yes. With for IoT devices, just export this. See here, TensorFlow with OpenCV Keras. Sorry, no-code tool Edge Impulse is there. That is to control all IoT devices, even simulate them. If I am taking IoT class, any IoT session, I'm not taking my devices there. I'm just working on Edge Impulse. For IoT devices, Edge Impulse is good, and there is no need to take any model. Just train like this. Basically, we teach our teachable machine, and similarly in Edge Impulse and other robo flow is there.
Can you show how means you have any demo for controlling the IoT object using Edge Impulse right now?
Right
Just-
now, we don't have time, I think.
Just I want to have the feel what happens.
Nahin, you want to take a feel, but that is need a time. Just there was a lecture in Chandigarh University in 2 months back, I think, in August or September. We used their Edge Impulse, totally Edge Impulse, and we talked a day-long sessions on Edge Impulse. That's why. Just check this. We have and you have a demos there. You have a tutorials there. Just go there and check all devices. AI for any edge device. You see now they have a logo AI for any edge device, and all edge devices, all type of things, even object detection, face recognition is there. Everything is there. Just go for that. Basically, with teachable, had you already seen that teachable machine, already worked on teachable machine? Just my one question before. Had you already worked on teachable machine?
No, sir. I'm hearing the concept first time from you.
Yeah, first time you are using teachable machine. That is,
Yes,
I
sir.
made interest in no-code tools to you. And really, just believe me, within 2 days, you will able to use this edge impulse.
Yes, sir, I'll try my best. I'll
Yeah.
try it.
Use that edge impulse and you will. And you can control, you can simulate, and you can teach your students. Because we are faculties here, and I am giving you the resources basically for your classes.
Sir, what will happen? Students will try to misuse these platforms. Just they will copy paste the code and just they will show us the demo that they have created this model. Yeah.
May I know your name?
And Deepika sir, Dr.
दीपिका,
Deepika.
हाँ दीपिका, ऐसा है कि स्टूडेंट्स को करने दीजिए ना, चैट जीपीटी का जमाना है ना? वी आर वर्किंग ऑन चैट जीपीटी डे टू डे लाइफ and other Gemini, other things are there, Perplexity, or many things are there. Students, they have, like, you remember our time when we don't have any mobiles, we have a landline there, and we remember hundreds of number, thousands of number, just on tips, typing and calling anyone, anytime. But nowadays, we don't even know our own number. Similarly, the ChatGPT time, they are making code, they are making, just do that now. They will, we can say कि हम उनकी क्रिएटिविटी को निखारते हैं, उनको बताएंगे तो वो क्रिएटिविटी और निकल के आएगी, कुछ ना कुछ अच्छा ही बना लेंगे. आपका वही एक स्टूडेंट जो सुस्त होगा. बिल गेट्स ने कहा है ना, जितने सुस्त लोग होते हैं वो सबसे बड़े इन्वेंटर होते हैं. तो डोंट थिंक दैट, जस्ट ट्राई, जस्ट गिव के एज इंपल्स होता है भाई, काम करके आओ. आप करोगे 3 दिन में, वो करेगा 1 दिन में करके आ जाएगा काम, और उसमें कुछ ना कुछ नया करके आएगा. करने दो ना. मैं तो ऐसा ही कोशिश करता हूँ कि अगर, अब तो मैं स्टूडेंट्स के साथ इंटरेक्ट नहीं करता, बट मेरी यही कोशिश रहती है कि मैं उनको रिसोर्सेज बताऊं. करने दीजिए, क्योंकि वो सुनते तो है नहीं, बुक्स पढ़ते नहीं है. आपका लेक्चर, मेरा लेक्चर किसी का नहीं सुनते हैं. उनको करने दीजिए जो करते हैं. हम तो उनको बता सकते हैं रिसोर्सेज कि हाँ भाई, यहाँ से ये कर सकते हो, वहां से वो कर सकते हो. ठीक है दीपिका?
Yes, sir. Thank you so much.
Anything else, please? Any question?
Good evening, sir.
Good evening. May I know your name?
This is Safia, sir. Safia Sheikh.
Safia, you are
Sir,
from?
due to technical issue, window is coming now, sir. Few minutes back, export your model. So there we get all libraries, sir. TensorFlow by default. Keras, sir, we need to select. Can you show me that once again, sir?
Yeah. It's just this.
Yeah.
One is TensorFlow JS. For our own website, there is a TensorFlow JS. Fine. You
Yes,
can make JavaScript files with that
Okay.
JavaScript or P5JS, whatever. There are different codes for both, and they are running on different things. Like that, for that there is a server required to run that code, and for that we have used Python server. On Python server, we can run that code, and that worked well. As
How
I
to add this, sir? TensorFlow. This. How did you add this one, sir?
just see, copy this, copy,
Okay.
है
Yes,
ना?
sir.
Go to
Ji.
your file, new project, text file, notepad plus, paste here, nothing else.
Okay.
Fine.
Yes, sir. Yes, sir.
Make this .html, save as
Okay.
index.html. Fine, save. Yes, nothing else. Now go to your Python code. Just I am closing this. Control C. I think that is with the help of Control C, you can exit from this. Why not going? Is this? Just close this, fine. And now go to your Python command prompt, CMD. Just see here, CMD.
Okay, sir.
And run a simple line of code that is just I am copying and pasting in place of writing here. C Python -m http dot server. That server is running now. And to use that server, for that we also using if I already told you that my system crashed in the morning, and that's why I'm using my nephew's system. And to run, there is three possibility. We can use npm, we can use our Windows server, Linux server, or this Python server. I'm using this Python server because the installation is easy and simply. Now, just localhost 8,000, fine. This localhost,
Yes, sir.
localhost 8,000. Now I'm going to my project, where my project is in downloads, my project is, and project name is TM project. When I run this, start, this demand your permission, camera want to start, and then we will give this permission for camera to running the camera, and that will run your code. That is simple.
Okay, sir. Thank you, sir.
Well
Thank
done.
you so much.
Anything else, please? Any other question?
Hello.
Yeah, please.
Very good evening, sir. This is Dr. Bharti from Pune, Maharashtra. It was very insightful and interesting session, sir. Currently, I am teaching IoT subject in which there are many sensors I have used for the practical purposes. My question is related to I want to, I'm proceeding with some book chapter related to ML applications in agriculture field.
Yeah.
So my question is regarding how, like for example, soil moisture related sensor is there. Some other sensors are there. How I can incorporate these particular IoT concepts and the practical oriented data whatever we reproduce by these sensors and machine learning models so that it will be helpful for the certain kind of things in terms of farmers they will be able to get to know, like for example soil moisture where it
I
will be
know about
giving the
that.
information
Just
like
Dr.
how much is the moisture, depending upon that how the watering will be done for the crop. So that is the example. So how I can make use of machine learning models along with the IoT to proceed for the application in agriculture field.
Yes, in agriculture for plant diseases, plant species, you can use Google Teachable Machine because with the help of species, you can just with the mobile net, you can pre-train, already pre-trained models are there and you can just retrain them and find out. But with the help of for sensors, there is TensorFlow mechanism is there, and you can download those models and apply on your edge devices like your sensors, which you are talking about in IoT devices. है ना? Similarly, if you want to go in detail, like watering, like fire, like moisture detection, that is there is uh, another tool that is Edge Impulse. I already told you. Edge Impulse is a very good tool, and you can go further. Just this lecture make you think about the no-code tools, not just I am making you perfect or clear. Just आप लोगों को एक चीजें बता रहा हूं कि हाँ ऐसा हो सकता है और एज पल्स में ऐसा होता है, ऐसा होता है. मैंने एक लेक्चर में इसके बारे में बात की थी. फाइन.
Yes, sir. Thank you so much. I will check for the details.
When you are going on your sensors, there is a need of low code programs basically, not no code only. Then there is a no code, low code, sorry. Low code means some transcripts are required to write scripts. You have to implement them with your devices. That's why there is a low code requirement always be. Not only no code.
Okay, sir, because for the practical purpose, it is Arduino and Arduino IDE. That is Arduino Uno board and Arduino IDE. These things are used.
आप यूज करते हैं, मेरे को मालूम है.
Yeah.
उन्हीं के लिए जो Arduino और Raspberry यूज करते हैं, आपको डिवाइसेस की जरूरत पड़ती है, आपको सेंसर्स की जरूरत पड़ती है. आप बस खोल के देखिए ना, वहाँ सारे सेंसर्स पड़े हैं उस पे सिमुलेट करने के लिए. आप सिमुलेशन बनाएंगे, आफ्टर दैट उन सेंसर्स पे उसको इंप्लीमेंट कर देंगे.
Yes, 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 sir, definitely.
आप बना के देखिए. Really, that is a very good tool. Yes, someone they're asking.
Thank you so much, sir. Thank you.
Welcome, welcome.
Sir, can we work on textual data also? Can we upload our files and check the model accuracy and using teachable machine?
Using teachable machine
on text data.
Text data, that is not very good model basically. That is not making object detection clearly. In textual data, there is a need of object detection, separating different objects and identifying what object is that, and separating them. That is very difficult.
Okay, fine, sir.
Yeah, yes, it can say you कि this is the textual data, but it can't say you this is A, this is B, or this is C.
Means like, for example, NLP also like a recommender system or human emotion detection system using
Uh-huh.
textual data. So we can't use these machines for that.
No. Because we are using just I already told you कि Google ने मैंने शुरू में फर्स्ट स्लाइड में दूसरी स्लाइड में इसके बारे में बात की है कि गूगल टीचेबल मशीन बनाई इसीलिए गई है कि जस्ट आप लोगों को एक्सपीरियंस हो, एजुकेटर्स को पता चले कि हम नो कोड से भी काम कर सकते हैं। बनाया तो उसे टेंसर फ्लो पे गया है ना, और टेंसर फ्लो तो एक पूरी की पूरी लाइब्रेरी है जिसमें पूरा कोड लिख देते हैं आप।
Yes, sir.
ओपन सीवी को पूरा यूज किया उसने केरास को, है ना, कन्वर्ट करके भी दे रहा है आपको, एक्सपोर्ट करके भी दे रहा है केरास में, ओपन सीवी में। तो मतलब उसने उन चीजों को खत्म नहीं किया है कि भाई आप उनका स्कोप नहीं खत्म कर रहे हो, जस्ट उनकी हेल्प लेके एक नो कोड टूल बना के दे रहे हो कि आप भी ऐसा सोच सकते हो, आप भी कोई नया नो कोड टूल बना सकते हो। और एजिम्पल्स भी कोई बहुत देर से पुराना टूल नहीं है, ये भी अभी आया है। आईओटी डिवाइसेस के साथ तो हमेशा दिक्कत होती थी, मैं आईओटी का लेक्चर ही नहीं लेता था, बट जब से एजिम्पल्स, रोबोफ्लो ये सारे के सारे हैं, मैं लेक्चर लेता हूँ, सेशंस देता हूँ उस पे आईओटी, और इसी वजह से दे पा रहा हूँ क्योंकि वो नो कोड हो गया, है ना। Anything else? Thank you very much. Please conclude, Dr. Gautam.
Thank you, sir, for your nice lecture. So we can conclude this session here. Thank you, sir.
Thank you everyone to listen me. And actually, very tired day today. My system crashes, and after that, I have prepared my presentation, today's presentation. Some part of presentations took from my last lectures, and some are new. That's why basically these two sessions are new sessions. I never give my previous session to in incoming sessions. कभी भी मैं अपने पुराने को रिपीट ही नहीं करता हूँ, और हमेशा उसको नया सेशन ही देने की कोशिश करता हूँ। That's why मेरे साथ इशू भी हुआ, और मैं सुबह से अपनी चेयर पे ही बैठा हूँ आप लोगों के लिए काम कर। Thank you very much.
Thank you, sir.
Thank you everyone.
So our next lecture, session 6, will be taken by Dr. Jyotsna Devi Bodavati, madam. So it's madam second session. Yesterday also madam take the first session. So please madam, you can start your session. Jyotsna madam.
Yes. Yes. Thank you. So a very good evening to one and all. So I can understand that you all must be having wonderful sessions and you all must be tired. Hectic day, right? Yeah. So hope the session will be interesting to you. So yesterday we had a session on OpenCV, right? OpenCV for computer vision. And today I came up with another interesting session. So let me share my screen. Today's session is on object detection and tracking. So welcome to the session, the second session of the computer vision. Like yesterday's session was on OpenCV for computer vision. And today's session, I will be focusing on object detection and tracking as a continuation to the yesterday's session. So let me give a brief overview of like what this object detection and where we are in the computer vision task. So where this object detection task stands in the computer vision task. So basically, these tasks can be considered as the basic standard tasks of the computer vision. So if you observe classification, semantic segmentation, object detection, and the instance segmentation. And I hope I'm audible and my screen is visible. Can someone confirm?
Yes,
please?
madam. Yes,
Yeah.
yes.
Thank you, sir. Thank you, sir. Yeah. So these are the standard tasks in any computer vision task, like classification, semantic segmentation, object detection, and instance segmentation. Of course, I'll not be going into any of these details. Let's make it what is the difference between, just to differentiate the understand the differentiation between classification and detection. I'll just give the overview. I'll just quickly spend 2 minutes on this. Yeah. So the classification task, if you look at, so here we are, then the image is given, we are trying to assign a label to the image, right? So in case of the standard classification task, we are identifying one label, or if it is a multi-label classification, we are trying to assign multiple labels if there are multiple like objects that are residing in this as part of the image, right? So of course, the set of labels that are already from the given known set, and that task we call it as a classification task. Then the other task is a semantic segmentation. So what the semantic segmentation is, say for example, if this is the image that is given, then this is how the semantic segmentation looks like. So in this task, what we do is we try to classify the pixels itself. We are not classifying the image as such, and we are also not classifying the objects as such. So we'll be applying the model like on pixels, like every pixel will be classified. And the pixel, if you consider this part of the image, this pixel is belonging to the sky or trees or cat or grass. So that is how the work happens in case of the semantic segmentation. So we are classifying the pixels of the image rather than the entire image. And this task, we call it as the semantic segmentation. Here, we are not differentiating the instances. We are taking care of the pixels and then applying the classification. And here also in this image, we are identifying the pixels are belonging to the cow or trees or sky or grass, what it is. So that kind of task, we call it a semantic segmentation. And the other task, the more interesting task and the task of today is like our focus of today's session is object detection. So object detection, just we move on to the object detection task. Let's try to understand the instance segmentation also. What is this instance segmentation? So in case of the instance segmentation, we'll be trying to classify each instance, not only segmenting the objects, we are also trying to understand this part of, or this object is belonging to one instance, and these pixels are belonging to the other object. And if you observe in semantic segmentation, so all the pixels that are belonging to the cow will be mapped into one of the class, right? So though there are two different cows here, that means there are two different objects belonging to the cow class, but still they're all mapped into the same kind of class only. Rather than doing that, in case of the instance segmentation, what we do is, so here if you observe, these two are belonging to the dog class, and then this is the cat class. So here this is also dog and this is also dog, but they are differentiated with different classes, and that kind of segmentation we call it as an instance segmentation. So similar to the semantic segmentation only, we will be classifying each pixel in the image, but if the pixel is belonging to different instances, they are classified into different classes, and that particular task we call it as instance segmentation. And now, like wherever there are multiple objects of the same class also, this kind of instance segmentation will be of great use. So the next task is the object detection task. So what is object detection? We are trying to understand or detect the presence or absence of a particular object, and not only detecting that, we are also localizing that is in which location it is present. So not by like pixel wise, we are identifying that through we are localizing that through a bounding box, and that kind of task we call it as object detection. So here you can see, so in this image, if you observe, so we are trying to get the bounding box for the image. I would like to identify or detect the presence of cat in this image. So then not only identifying the yes or no part of it, in addition to that, we are trying to understand its location also. So that is what the object detection task is. Now in this lecture, we'll try to understand various, at least few of the models that can be used for the object detection task. Then how do we implement that? Maybe a simple code snippets we will have a look, and then if possible we will also look at how to track the objects. So maybe in case of object detection, so we'll be trying to understand the detection and also the localization in a particular single image. In case of tracking, we will be applying it on different frames of the video, and then we'll be tracking also. So in how many frames it is the same object is found. So that is what the tracking is. We'll discuss that a little later. So let's focus on the object detection part. So in the very standard approach, how we can solve it. I hope all of you have the knowledge of the CNNs and how they can be used for the classification task. You can use your VGG, or you can use your ResNet or exception, or you can even create your own custom CNN for the classification task. I hope all of you have that sound knowledge on that. Then you can better appreciate it. Otherwise, it will be a question mark for you. Yeah. So now let's see when we design the object detection, like maybe in the very naive approach, how we can design that is, it's a combination of two different tasks. We can consider the object detection as, so, and I'm assuming that my image contains only single object, then how we can deal that. So that's what we are trying to understand. So object detection is a combination of two different tasks. So one is a classification and then localization. So what is this localization? Identifying the region where that object is residing. And we will be drawing that bounding box, and that part we call it as localization task. Okay, and how we can achieve this like classification along with the localization is, so the given image, maybe during the training I'm talking about. So for the training images, we'll be having the ground truth also. So what is that ground truth? So given this original image, I'll be knowing that the image is belonging to the image is having the presence of the cat object. And also, so this is a starting coordinate of the object cat, and like this is the height of the object and this is the width of the object. So with this rectangular bounding box, I can localize the object. So these are the ground truth values that will be available with us. It's not only classification, please understand, as a combination of both classification and localization. So of course, because there's a classification, we can use the classification, like the CNN model for the regular CNN, any whatever the kind of CNN you would like to use, any complex CNN or the simple CNN you can use. And you can, yeah. So here if you observe, we are passing this image through a CNN model, and then, so maybe through the final fully connected layer, anyhow, finally we should pass through a softmax layer so that we'll be getting the class probabilities, right? Yeah. So then it is attached, the CNN is attached to the final softmax layer. So maybe 1,000 category softmax layer, 1,000 neurons softmax layer. Then I'll be getting the probabilities, right, at the output when I pass this image. And I'll be getting the class scores. So by the model, when we train this model. And along with that, not only this part. So this part of the network will be doing the classification part. And in addition to that, we need to have the localization also. Then what are the values that are representing this localization? The starting coordinates, that is x and y, and the width and height of the bounding box. So 4 coordinates are needed for representing this localization. And so this will be passed through these 4 values also. So like another fully connected layer will be connected to this part. There are like 2 different decoders you can consider this as. And then this will be having, there are 4 different neurons. Again, the softmax layer or the linear layer you can have. And be providing those X, Y, W, H values at the output layer. And now, so once you are, you train the model, these are values that are provided, like produced by the model, predicted by the model. Then, so how do we train the model, or how do we compute the loss of this complex model is? So for this classification part, this will be taken care by the softmax loss, as we do it in case of any of the classification, the deep neural network based classification model. So we'll be using the softmax loss, and of course we have the ground truth, and we'll be comparing that using the softmax loss. We get the softmax loss. And on the other side of the localization part, so we consider the L2 loss, that is the regression. Like you can consider it as a regression problem, and because we are trying to predict the coordinates, right? So coordinates means there are the pixel values or like numerical values. That is where we are posing this part of the network as a regression problem. And you know the ground truth values of this x, y, and the width and height. And these are the predicted values by the model. Then the comparison between these two can happen with the help of the L2 loss. And so this is one loss and this is the other loss. And the total network loss is, so what is your objective? The object detection, right? Object detection is a combination of classification and the localization. So the model should be able to do the classification and at the same time the localization also. That is where we'll be going for the loss, which is the multitask loss. We call this as this complex loss as the multitask loss. Why are we calling it as multitask loss? So it is predicting the bounding box and also it is predicting the class label when the image is passed through this model. And that is where we need the multitask loss, right? Yeah. So in the simplest scenario, this is how we can design the model. Okay. And this is under the assumption that the image is having only one object. Then only this is valid. Please understand that. Okay. We're going to like for the complex scenario now. So now this is how the softmax loss plus the L2 loss, you can combine it and you can use like call it as a multitask loss and you can train the model using your back propagation. This is all the like the regular task. And when we go for the multiple object scenario, so when we relax the constraint that the image is having only one object, we are relaxing the constraint. So now we consider that there is a possibility of having multiple objects also. Then, so what the model should predict, of course, the classification wise, it should predict for the first example, the image, the object present is the cat. So it should predict the label cat along with that bounding box like X, Y, and WH values, right? And what about this image? When I pass this image, there are three different objects that I'm interested in. So like there's a dog, and there's a cat. Of course, there is the Xmas tree and the pillows, sofa, couch, all these are there, but I'm not interested. At least I'm interested in these three animals. Then your model should produce three labels, dog, and cat, right? And their coordinates also, their bounding boxes also. And in this case, the next example, if you observe, I'm interested in finding the duck. So where there are like multiple ducks. And maybe in this image, there are 10 ducks, and in the other image, there could be 50 ducks also, right? Then how do I deal with this? Maybe all the, for all the objects, there are ducks. Of course, the label should be found. And along with that, it should be able to find the coordinates, the bounding box coordinates also for all these objects, not only for one single object, for every object it should be able to find. And now, can I apply this kind of approach? We cannot, right? This works only when we assume that there is only one object present in the image. So that is where the simple approach, the naive approach fails when the object contains multiple objects. So that is where we are going for, like if you observe, so this image contains like one label and four coordinates, and here in this case, 3 labels and like 12 numbers you need to predict, right? And here in this case, maybe 10 or more than that, the labels, and also like multiplied by those many coordinates. So this is a problem. So that is where we cannot do that. So when there are multiple objects, so you cannot apply this, right? So what we can do, so we can apply the CNN now. So here we are applying the CNN on the entire image, and then we are getting the predictions done. But when there are multiple objects present, this is not working. And that is where we are going for like applying the CNN on part of the image. If you observe, so on this part of the image, we are cropping and then we are applying the CNN. And then this part of the image, so is there any dog or cat or any background? I'm checking it. So dog, no. Cat, no. And background, yes. So that is how I can get like only one label, and its coordinates also I can get, right? And similarly, maybe I'm using this window. And now in this window, if you observe, yes, dog is present, cat is not present, and background is like no, right? So now instead of doing it for the entire image, I'll be applying it on like a window or like part of the image. So a cropped image I can consider, and I'll be having different props of the image, and I'll be applying the CNN. So this is the approach we can follow, right? So maybe under this part of the window, so you can identify that the cat is present and there is no dog and no background. But is it feasible to apply this approach for the entire window? So what is the problem if we proceed with this approach? The problem is your bounding boxes, or like the window you are applying it's not of the same size also. Here, if you observe, so in all the cases, the bounding box is different. Can you see? The bounding boxes are different in scale and also like in sizes. So that is the problem when we use this approach for identifying or detecting the multiple objects from the window. So cropping the image with and overlaying the window from like multiple images from the original image and applying the CNN on every part of the image and then applying this original approach. So may not be feasible because it's computationally expensive. So that is where the problem lies. So this is not feasible. That is where we are going for the like, of course, it's all like about the literature only. So we go for the approach called as a selective search, or we call it as a region proposals. Of course, I'm not going into this very detail of it. If you are interested in, you can go through this these papers which are published in 2012, 13 and 14. Those are like very detailed approaches. You can go through it. So this is a regional proposal. These are all like old approaches, like 13 years old. You can go through the literature and understand. So what we do here in this approach is we'll try to, rather than like identifying every, like applying the CNN on every window of the image, what we do, so we try to get the blobby image regions. Not every region we get. So we'll be getting the blobby region. So what is this blobby image regions? The regions which are having the possibility that there is an image, there is an object. And that kind of the block, we call it as blobby image regions. And this, the algorithm which get this kind of regional proposals are known as the regional proposal algorithm, or you can call this algorithm as a selective search algorithm. And this algorithm can, can give 2000 region proposals from a given image. And of course, this algorithm works only in few seconds on the normal CPU itself. So that is how the algorithm is designed. You can try it out. You can understand from these papers. So now you can see, so given this image, few of these are the region proposals that are derived from the selective search algorithm. And here, if you observe this box, if I consider there is a flower, and here also there is a flower, and here this is another region. So which may contain an object, right? So such kind of 2000 different regional proposals will be provided for us, and from those regional proposals we'll be applying the CNN now. So that is what the CNN, we call it as RCNN. It stands for Regional Convolutional Neural Network, region-based convolutional neural network. So shortly we call it as RCNN. What it does is, first we apply the region proposal algorithm on the given image. Then, so for every proposal that is given by this regional proposal selective search algorithm, then we apply the CNN on top on that. Okay, you can see here. Yeah. So this is one region proposal, and this is another region proposal, and another region proposal. So then, like that, we get 2000 different region proposals from the image when you apply the selective search algorithm. Then we apply the CNN on every part of that such a region proposal, and then so we'll be applying the same old algorithm that whatever we discussed earlier, right? So the ConNet, we are passing the region proposal to the convolutional neural network algorithm. Then of course the final layer can be attached to this VM, assuming that the features are used, and then you can even attach this network to the regression algorithm also, where you are finding the bounding box. So this is how you can like apply, like you can identify it. Okay, so this is like the problem with this kind of approach is, and this approach we call it as RCNN, so region-based convolutional neural network algorithm for object detection. But the problem with this approach is there are 2000 different regions that are possible, and passing through every region into a CNN, it will be too much expensive, computationally expensive. So it is called as slow RCNN, we call it as. And rather than doing that, what we are going to do is like fast RCNN, like how the object detection evolved over the period of time. I'm just giving the overview of it. Okay, please try to understand it. So then the fast RCNN came into picture. So what is fast RCNN? So this is what on the this here you can understand. This is what we discussed earlier. The slow RCNN, where every region proposal is passed to the convolutional neural network. Then we are like attaching it to the classifier along with the regression model, right? Rather than doing this to make it faster, then what we are doing, we are first passing this entire image to the convolutional neural network. And so we'll be getting the feature maps, and on the feature maps algorithm, on the feature maps, we are applying the region proposal algorithm, like the selective search algorithm. So maybe from one of the convolutional block, like maybe block 5, block 6, whatever, depending on the connet you are using. So you are getting the region proposals. And to that region, like region of interest, so you are applying the CNN. And then you will be getting the class, and then you will be getting the object category or the bounding boxes. And so this algorithm is pretty much fast compared to this slow RCNN. Okay, so you can observe this. So this is how like RCNN works. So what is this RCNN? RCNN is regions with CNN. Just to summarize, you're passing the input image and you are extracting the 2K, like 2000 different region proposals, and then you are passing each of these region to the CNN, and then you are classifying, and along with that you are passing them to the regression model also. Or otherwise you are passing through a single CNN, and then you are getting the region proposals. So that is a faster and slower versions of the RCNN. But in either cases, the problem is there are 2000 different region proposals you will be getting, and passing through every region proposal. So like proposal plus classification you are doing. So the problem here, the shortcoming or the limitation of this approach is it is very slow. And when you would like to apply the object detection in the real time, then it is not possible at all. And optimization is really, really hard. So these are all the limitations of this RCNN approach when you use it for the object detection. And that is where, right? What is better then? So the problem can be solved using you can pose it as a regression problem. So what is new is the regression approach that we would like to follow rather than considering it as a classification approach. And how this works. So let's have a look. Now we are going to pose a problem as a regression problem. And of course, to design that, so we are using the YOLO model. So YOLO stands for you look once. And this is the model. Of course, very recently, YOLO 11 is also released for the object detection, which is pretty much faster and pretty much generalizable also for the real world object detection. So now let's have a look at the different features of the YOLO. Extremely fast, of course. So fast in the sense you can process 45 frames per second. I'll show in real time also while giving the demonstration. So quickly it will run like 45 frames per second. It can process it and reason globally on the entire image. Like it can detect the images or the objects entirely on the image, and it works entirely on the image itself, not on the proposals. That's what the meaning of it. And then learn generalizable representations. So these are all the unique features of the YOLO object detection model. And now let's have a look at the procedure, like how it works. Please try to understand as much as you can. And of course, what we have seen so far, so we have seen what the object detection problem is, and then what are the different approaches that we can use. So when it is single object, then maybe you can pose it as the classification plus the regression model. But the problem is when there are multiple objects, then it is not possible to pose the problem as a classification plus the regression problem, right? That is where we are moving towards the RCNN approach, but it is too slow because there are 2000 different proposals that are possible, and running a CNN algorithm for 2000 times, it is not possible in real time. And that is where we are discussing about the YOLO approach. So it is really faster and it is suitable for the real-time applications as well. That's how it has grabbed the attention of the deep learning community. And now let's see what is the procedure that is followed by the YOLO detection algorithm. So now given this image, what we are going to do is we are dividing the entire image into grids. And the grid is maybe S by S grid. So here I assume that it is a 7 by 7 grid. We are dividing this entire image. Okay. So maybe depending on your application, like typically in YOLO, it is a 7 by 7 grid. And now you can see like the entire image is divided into 7 by 7 patches. Now, so once you divide the image into 7 by 7 grid or patches, then we'll be applying this, this algorithm will be applying, or this kind of representation we will be applying. So what we did, so we have divided the entire image into like S by S grids. Typically S is 7 here, and for every cell here, for every box, so there are like 5 plus k number of quantities we need to predict. Okay, and what are these 5 plus k quantities that we are going to predict? That is what we need to understand. Please observe. So for every image, we'll be having the confidence score and the width of the object, the height of the object, and the center of the coordinates of the object, x, y, because we need to get the bounding box, right? So that is what. So say, for example, this is the bounding box you assume. And for this bounding box, so what is the confidence that the object is belonging to or the object is present there? That is what the confidence is. And what the width and height of the bounding box. Then the center pixel or the starting pixel of x of the bounding box. And then there are k number of probabilities. So for every cell that is present here, you are going to predict all these 5 values. And along with that, these 5 values also. What are these 5 values? Or sorry, not 5. There are like k different probabilities. So what are the k probabilities here? K is related to the number of classes. So assume that here there is a car, there is a bicycle, and there is a dog here. There are 3 different objects that I'm interested in. So then the number of probabilities you would like to find is 3. Okay. And if you assume there are 5 different objects that you would like to detect, then so the number of classes, that is k equal to 5. So there will be k different probabilities. What is the probability? Say, for example, this is the bounding box we are looking for. And for this bounding box, sorry, not bounding box, this is the cell, right? Yeah, for this cell alone, so we'll be identifying or we'll be having this kind of representation. And here, these are 5 different values and these are k different probabilities. So what are these 5 different values? The confidence, the width, height, and so x and y values, the center pixel value for this box. And along with that, we'll be having the probabilities. What is the probability that this cell is belonging to the cow object? And what is the probability that this is belonging to the dog object? And what is the probability that it's belonging to the car object? And what's the probability that it's belonging to the truck object? And what is the probability that it's belonging to the tree object? Okay, so that is what we are trying to understand for every cell. And here you can see, so I hope you understood. If you have any doubts, please feel free to interrupt me at any point in time. I'll not be checking the chat box. Please interrupt me and then clarify your doubts. Okay, yeah, thanks. So now these values are like the probability, the width of the bounding box, the height of the bounding box, and the center of the bounding box. And along with that, the probability that the cell is belonging to each of the classes. If there are k classes, then you will be having k different probabilities. And so like this, you will be having all these values, the 5 plus k quantities for every cell or every grid. Okay. And so that how many different grids you have? How many grids you have in this case? 7 into 7, right? So that is 7 rows, 7 columns, so 49 grids. If you assume that 7 is yes, it is s into s by s, right? S into s grids. Now for every grid, again, you have all these values, 5 plus k. So that is where, so your output layer of the neural network, if you assume that you are passing it to a neural network and you like to pose it as a regression problem, then your output layer should have s into 5 plus k neurons, right? It should be able to predict all these values. So I hope you understood what we are going to do now, how we can solve the problem. Right? So this is how we are posing the problem in case of YOLO. Now, each cell predicts the V boxes. So the X, Y, and WH, that is the center of the bounding box and the width and height of the bounding box and the confidence for each box. That is the probability of the object. What is the probability that this box is having the car object? And what is the probability that this object is having the dog object? So that is what we are trying to understand. Now let's see. So now you can see each cell predicts the boxes and also the confidences. So both for every cell we'll be finding. And now, so you can see we'll be finding for the bicycle. So if you observe, this is the if you look at the confidence scores and all, and this is a box that is belonging to. These are all the boxes that are belonging to the cycle object. No? And maybe these boxes you can consider they're belonging to the dog class. And these are the boxes that are belonging to the car class. And maybe if there is another object like dining table or like floor, then they are belonging to this floor object. Okay, so this is how they will be identified as the objects. So that is what happens. Considering this region alone, and this region is belonging to the dog class, right? So what is the probability that this box is having the dog? Yes, it is having higher probability. It's 0.8. With 0.8 probability, this box is having the dog class. And is there any chance that this block is belonging to the cat class? It's 0 probability. And similarly, bike class or the car class, no, right? It's a 0 probability. And similarly, for every cell, we will be finding all these. And this is the value we call it as what is the probability that it is belonging to the car given the object. So that is what the conditional probability will be finding. And now, so the probability of the class can be found as the multiplication, the product of these two probabilities. The probability that the class given object into the probability of the object. So both these values will be, with these probabilities will be multiplying, and that is how we get the probability of, this is actually the joint probability. So that is where we get the probability of the class. Okay, and then we use after getting these probabilities, we'll be applying the thresholding for detecting the bounding boxes. So once the higher, once this is found for every box, then we'll be applying the threshold, then we'll be removing all the thresholds which are the values that are less than the given threshold. So if you observe, this is the box which is having the higher threshold for the dog class. So we'll be retaining it. And this is how we label this box as the dog class. And this box is, we label it as the bicycle class because it is having the higher probability of the object cycle. And this is the box which is having the higher probability of the car class. So that is how we detect the objects in case of the YOLO. And maybe the network, if you look at the network, how it works. So we'll be passing the input image, and then we'll be passing this image through all these like different, layers of the model. And then here you can see these are all the convolutional layers. And then this is the fully connected layer, right? And then this fully connected layer is reshaped into 7 by 7 by 30. Then the detection procedure happens here. So that is how it happens. Okay, this is the inferencing. And of course, these models we are, this is the GoogleNet will be, which is a pre-trained model. So we'll be using it for getting the initial features, and then we'll attach few more convolutional layers and then the fully connected layers, and that is how the network is designed. And if you observe during the training, so what we will do is we'll try to match the example to the right cell. So maybe in this cell, so this is the center of the pixel, right? Yeah. Then this block is belonging to the dog class or the cat class or the bike class. So that is what will be coming up. And then, so not only for this, and we'll be moving one box towards the right, towards the up, towards the down. And that is how we'll be extending the box, and we'll be trying to understand the probabilities. And maybe if you consider this box and this box is higher chance that this is belonging to the dog class than this box alone, because this box is part of the inner like outer box. That is where we neglect this box. So that is how we'll be predicting the boxes. Of course, there is all these boxes will be predicted, but whichever is like having the outer, like which is having the best fit. So that is the box we'll be considering, and which is having the highest confidence box that we'll be considering, and rest of the boxes will be ignored. So that is how we'll be getting the predicted object. Okay. Yeah. And similarly here, if you observe, this is belonging to the cycle class object. Okay. Yeah. So now let's see. Yeah. So the loss function that we are using is, so if you observe, it's a MSc loss we'll be using, because we are posing the problem itself as a regression problem, right? So for the regression problem, which is more suitable, the suitable loss function is the sum of squared error. And we have all the different values for every grid. So what are those values? We'll be having xi's for every box, right? And for all the s square different grids. So that is where you will be using, this is summed over every box, and also for every s square, every grid. And total grids are s square. And this is for the coordinates, the x and y coordinates. And we'll be having the weightage. So this is the hyperparameter or the scaling parameter, that the weightage that is given for the coordinates. And similarly for the width and height parameters also. And this is the scaling factor that is given for the width and height coordinates. And similarly for the confidence scores also. For every box, you are trying to understand the confidences. And here the hat indicates the predicted value and the CI value is the ground truth. And similarly for every parameter you are taking. Okay. And you can see the probabilities, like here you can see the probabilities of each and every class. And if there are some fake classes, then this function should sum over all these classes. So that's how we design the loss function, the complex loss function that is used in the YOLO object detection model, the sum of squared loss, of course. Okay, and of course, this is the example. You can see when you pass this image, then you'll be getting this as a person, this is another person, and maybe there's a bottle here, and this is the dining table image that is being detected. Maybe this is the image. You can see here, this is just a painting, but still here there is no person, that's just a painting, but still it is able to detect. That's the power of the YOLO, YOLO generalization. Okay, yeah. And here, this is the person it is detecting, and this is the cat is detecting it as a cat. And you can see here, this is detected as a person also, though the person's face is not available, it still is able to detect it as a person, and this another person, and this is the umbrella. You see here, and this is like almost merged with the background, but still it is able to identify that. So this is how the YOLO works. This is the power of YOLO. And if you look at the strengths and weaknesses of the YOLO model, it is very fast, as we discussed earlier. So it can process 45 different frames per second. And the smaller version, if you take, it can go up to the 155 frames per second. I'll shortly discuss with you different possible models that are possible with YOLO. And you can do it like end to end. You need, like, say for example, the YOLO, the standard YOLO model is designed for the generalized objects. It is basically trained on the data set known as COCO object, which is having 80 different classes. Maybe if you would like to do it for your own application, then you have to train it. So training is also possible, like end-to-end training is possible for your own data set, and the background error is also very low. So these are the strengths of your YOLO model. And your weaknesses, if you look at for the limitations, the performance is lower. Like if you look at the older versions, of course, it depends on the version you are using, and it makes more localization errors. I'm talking about the basic standard version of YOLO. Okay, now let's go ahead to the demo, and then we'll look at different YOLO models. I'll quickly go through the YOLO family and all after the demonstration. Okay, I'll give a pause for half a minute so that you can, if you have any doubts, maybe I can clarify. No doubts? Okay, I'll take the and yeah.
Ma'am, I am Jagdish from AICTE University.
Yes, sir.
Thank you, madam, for our excellent session on this object detection.
Yes, sir.
Really, it's very interesting, madam.
Yes, thank you.
Madam, now I have a doubt. Suppose we train a model for a say for a real images,
Okay.
like any real world images.
Yes,
So,
sir, you can do it. Even for the faces also we can do it.
Yes, madam. Suppose let us say the image is given with a noisy environment.
Okay.
So will our model still is able to detect the object in case of a noisy environment if it is not trained previously? So this kind of images.
That depends on the noise that is present in the image, sir.
Yes, madam.
To what extent the noise is present, it depends on that, and depending on the training set that is used for the training, the data set that is used for the training also. So if you use augmentations and all, like Gaussian blur or pepper noise, and to what extent the noise is present in the augmentation. So all that matters. So that simply we cannot say that.
Yes, madam. Because if we apply the same concept to a autonomous cars.
Yes, we can do that. So autonomous cars means like for like computer vision part.
Yes, madam. Yes, madam.
Yes, sir. We can do that, sir.
Okay, madam. And thank you, madam.
Yes, sir. Okay. Let's see the demonstration of whatever we have discussed so far. I'll now give you a quick demo of how we can apply the object detection using YOLO V8 version I'm using because this is pretty fast and I can show that in Collab also. And maybe you can try with advanced models also. That might take little more time. I can manage this version with the Collab. That's how I have used it, YOLO 8, okay, YOLO version 8. And I hope my screen is visible and the letters are visible to all of you. Is it
Yes, ma'am,
fine?
visible.
Yeah, thank you. Thank you, ma'am. So object detection using YOLO V8, if you would like to implement this, I'm not going to, show the training of the YOLO V8, but how to use it for the object detection purpose. I'm giving the demo on it. Like you can use the Ultralytics package, the Python library. So they provide the library functions, the Python supported libraries for the object detection, typically the YOLO V8 versions and all. They're giving it for free, you can use it. And before you use the YOLO V8, you have to install this Ultralytics package. Okay, yeah, this is how you can do that. Like pip install Ultralytics, you can do that. And once you install it, you go and download all the relevant packages that libraries that are required. Here I am importing like YOLO model. So because I would like to work with the YOLO model, and that's where I'm loading the YOLO class, and I am importing the files method also from the Google Colab because I would like to upload the image as a file. Okay, that is where I'm importing this, and then I'm importing, of course, OpenCV because I'm working with the images. So I'll be importing the OpenCV for the computer vision related tasks. It's what we discussed yesterday. And of course, NumPy, because the boxes, the bounding boxes and all will be presented as the NumPy array objects. That's where we are importing this. And of course, for the visualization, you can use the computer vision, like CV, OpenCV, or you can still use the Matplotlib. Either you can use, okay? And this is where we are importing this. And maybe I'll be sharing this notebook also. So for your understanding, I have given every detail of it, okay? Every detail of the statement of the code I have given here. Okay, you can go through it. Yeah. So one thing we need to understand is, as we discussed yesterday, if the image color coding for the images is like PGR color coding. It's like, it's not RGB. It is blue, green, red color coding. And if you would like to use the Matplotlib for visualization, you have to first convert it into RGB and then only you can visualize it. Please understand that. Okay, have that in mind. And that's a point to be noted. And what we have done, so we have installed Ultralytics, and then we have imported all the libraries that are required to work with the YOLO. And object detection is basically on a single image. That's where I'm going to load the image shortly. And prior to that, you can load you create the YOLO object, YOLO class object you just create, and which model of your YOLO version you would like to use, that you can mention. So here I would like to use a YOLO 8N. Okay, here PT stands for the PyTorch. The PyTorch model we are going to download. Here N stands for the Nano. And Nano is very quick and like simple model. That's why like to show the demonstration quickly, I'm using this YOLO version 8 Nano. Okay, and if you would like to, if you can spend time and if you would like to have good performance, then you can try other models. So maybe once we are done with the demonstration, we'll go and have look at like different types of YOLO versions that are supported. Okay, yeah. So that is what we are creating, an object of the YOLO model. Okay, YOLO class basically. Now the model is ready. The model is loaded. So once you execute the statement, your model will be loaded into your Python environment. Okay, and if you are already done, like once you execute it, if it is loaded into your environment again and again, you can use it without like re-downloading it. Yeah, so that's how you can do. And maybe if you would like to have better performance, you can try this. Like rather than using YOLO 8N Nano, you can use S, the smaller version, the medium version, or the large version, or the X version. Any of these version you can use. Okay, that depends on like depends on the accuracy you would like to have, the performance you would like to have, and of course because the models are a little complex, they take much time. That's the difference. And now I'm going to upload an image here, and for that I'm using the CD commands. And I'm using collab, so I'll be using files.upload method to upload an image here. Okay, and I have already done this. I'll run and then show you. Okay. You can see the real-time performance of this, like loading of the model and all. It's very quick. It doesn't take much time. I'm just loading one of the image, maybe the animals image. Okay, the image, like we uploaded the animals image. Okay, and then I'm going to apply it on this image. So I'll just show you what is the image that I uploaded. So I have uploaded this image. Okay, so that is where yesterday I have discussed about all these methods and all. So you're reading the image and then you are displaying the image. You are visualizing this image. So just it is having a couple of animals. Okay, and this is AI generated, not the original image. Just to use it for the demo, I'm using it, and then you can detect the. You can apply the detection, and how you can do that? Model.predict method you can use, and the image you have to pass here. So to the source as a source argument, source equal to image path. Okay, and what is this image path? Image path is the actual path where your image is loaded. So I have already loaded the image path to this, like to the image path, and that is what we are passing. And then the confidence I'm setting to 0.5. And what is the meaning of it? We have already seen that, right? So if the bounding box is having the object with the confidence of 0.5, then only you consider this as an object. Otherwise, you don't consider it. So that's the meaning of it. Here, what is it showing? So after detecting the objects, after calling this predict method, so it has detected, you can see the detected objects are also displayed here. One cow. Is there any cow? That's not correct, right? Yeah. So one elephant. Yes, there is an elephant, and one giraffe. One zebra, right? So these are all the objects that are being detected. So maybe there's no cow, right? Because the confidence is 0.5 only. That is why maybe it is giving a false positive. Now you can see when my confidence is set to 0.8, it is confidently saying the elephant is present. So it is two results, so you can reduce the confidence. And then out saying like one cow, one elephant, one zebra, and one giraffe. Yeah, of course, it's an AI generated, that's right. Maybe it is not working. So like you can see, but still it is able to identify the other objects perfectly, right? You can try some real images. This works really well. And you can see how much time it has taken to process this image. It has taken 463.6 microseconds. So that is the speed. Okay. Yeah. So now you can say, and what is the value that is returned as a result? So results is the value, the object that is returned as a result of this model.predict. So it has predicted all the objects, and the bounding boxes, the objects, everything is there in this results object. And I have displayed it for your understanding. Here you can see the results. Okay. Yeah. So what is there in the results? So in the results of 0, it will be having all these values. So for every object, what are the boxes, what are the mass, or like what is the plot, everything will be like available. This is how you can check if you are interested in, and you can see the results actually contains all these values. So what are the values? The first thing is there are no key points that are being detected, and the boxes, yes. So it is returning the boxes object, and there are no masks also that are being detected. And so actually the YOLO model is trained on, it's pre-trained on COCO data set, and the COCO data set, it's COCO stands for common objects. Okay, and the common objects, 80 different common objects are available in the COCO data set, and these are all the names of these objects, and these are all the IDs also. So 0 stands for here. You can see one cow, right? Yeah, there is a cow. And here cow, where is the cow? Here you can see cat object means the ID number is 15. And horse is present means the ID number will be 17. So that is how you can, you can see the mapping and what are all the numbers, the class IDs that are belonging to different names of the objects. And there is a possibility of finding 80 different objects. And please understand, the object will be identified only if it is these 80 objects. Otherwise, it will not be able to identify that. So that is why it is not able to identify this ostrich and also like hippo, all these things. Okay. Yeah. So that is what it is. And along with that, it is like object bounding box. No, it is not finding it. And the original image, it will be displaying the original image also in the results as part of the results. And along with that, it will be returning the original shape. So what is the shape of the image that I uploaded? 189 by 267. That is the image, and there is a path, all these details. And along with that, so if you would like to see the boxes, so results of 0 dot boxes you can see, and it will be returning the class of like what are classes that are being detected. I think I need to run this. This is like, now you can see what are the classes that were found. There are 4 different classes, right? 20, 23, 22, 19. So these are the 4 classes that are being detected from your object that you submitted. So now you can see 20 means what? So what is 20 here? 20 must be a cow. Oh, it's an elephant. You can see. So now it will be, this is how you need to map the objects that are being detected and their names. So the class names and the confidence thresholds. And here you can observe that with 0.83 it is saying that it's an elephant, and 0.77 it's detected as being this object. And similarly with 0.79 and 0.70 it is detecting it as this object. So this is how you can look at the confidence values and you can adjust the confidence values. Okay, and then the entire data, this data set tensor will be giving you like there are four objects that are being detected. So there will be 4 different tensors, like 4 different 4 by 6 values, right? This is the scores. Here you can see this is the object class label or the class ID, and this is the confidence value, and these 4 values are the X and XY value and the width and height values. So all these values will be displayed as a tensor. And along with that, it will be displaying the ID. Its ID is set to none, and we are not using any tracking. If it is a if you pass a video, then automatically this will be set to true. I'll shortly show that also, how to work with the videos. Then the original shape, all these things will be displayed, and then in different like X, Y, WH, this will be presenting your X and Y coordinates and width and height, and similarly the normalized values of it, and X min, Y min, all these values will be displayed. And now I would like to, like, once we get these results, we would like to overlay here. You can see, I'll just run it and show you. We have detected the animals, right? Yeah, the model detected the animals, and now I would like to get the bounding boxes. So how do we do that? Here you can see this is a zebra, and it is saying this is an elephant, right? And of course, this is wrongly predicting it as a cow. And this is a giraffe. It's finding these objects. Of course, we got that in the result, but how do we get these kind of bounding boxes? So I'll shortly discuss that. Yeah. So this is the image we have read, right? Yeah, from this part, we have this image. And then for every box that you have in the results of 0 dot boxes, so for every box, what you need to do? So you have to get your X1, Y1, X2, Y2 values, and they are available in box.xy, xy. So here you can see in the box you have XY, WH, XY, all these things you have. And I am interested in this, and this is required, this tensor is required for the bounding boxes, and that is what you need to get. So those values will give you the starting coordinates of your bounding box, and then the X2 and Y2, that is the height and width values. You can see X min, Y min, that is the starting coordinate of X and Y for the bounding box, and these are the width and height values. And now the confidence score, the class score, because when we are overlaying it, in addition to the class name, we are displaying the boundary, the bounding box, then the class name, and also the score. So to display all these, we need to have that, right? And the class label, I have already shown you where the class labels are, where the confidence scores are. So all that you just get it from your box.confidence, box.cls and all. Okay, the ID value and the name also. Then you whichever color you would like to have, this is all like you can try it out. So whichever color for the object, like you should present each object using different bounding box. Otherwise, there will be overlap. You cannot understand when there are multiple objects. That is where we are getting the color code. Then you draw the bounding box. The bounding box is just simply you are doing with a rectangle. That's it. So on the image, along with the image, you are displaying X1, Y1 and X2, Y2. And the color also, that's it. And this is the thickness of the bounding box. And then you create the label also with some font, and then you label the text as well. So that is how you are getting the bounding boxes and the labels. Then you convert the, like you just adjust the figures dynamically and then show it. So now you call the IM show, or you can use the matplotlib also. Either of these you can use to visualize your objects. The original image along with the objects. This is how you are showing it, right? So I hope it is clear. Let's quickly see what are the different YOLO models that you can try it out. So you can try YOLO version 8N or 8S, 8M, 8L, 8X. Not only 8, you can even try 9, 10, even 11 also recently released. Any of these models you can try. So here you can see, you can take a trade off, like the size, what is the size of the model, like speed of the model and the accuracy of the model, and use case when you can use it. Like depending on that, you can choose the model. Like N stands for the nano, S stands for small, M stands for medium, L stands for large, X stands for X large. That's it. And the naming convention, of course. And coming to speed, like nano is like the fastest, and small is also fast, and medium is slower, and large is slow, and of course X large is the slowest. Of course, this is a the processing speed. And coming to the accuracy, so of course fastest means that's a slow in accuracy, and slowest because it's more complex. That is how it's a highest in accuracy, the performance wise. So you can take a trade off what kind of model you have to use, and the use case where you can use it. So when you can use nano, and if you are working with a CPU alone for the real-time demos and all, you have to use a nano model. And if you are working with small projects, maybe a moderate accuracy is fine, then you can go for the small version. And similarly, like you can take a good balance between the speed and accuracy, then you can go for the medium level model. And the research level accuracy, if you are interested in, then you have to go for the large version. And if you have a GPU and you can manage with this computational cost, then you can go for the Excel version. Okay, yeah. And of course, you can go for the YOLO version 9 also. And similarly, in YOLO version 9 also, you have different models. You can try them out. And here T is a tiny model, then S stands for small model, and M is a medium, and C is a compact but with high performance, and E is the extended version. So these are all the different versions that are released in the YOLO version 9. Okay, different models with YOLO version 9. And with 10, with version 10 also we have different models. Similar to the 8, we have nano, small, medium, large, etc. And remaining things, of course, you can understand. So when you are working with the real-time edge AI and tools, then you can go for the YOLO version 10. So of course, latency is improved and computational cost is reduced. So that's the benefit of using version 10. And you can even try with YOLO 11 also. And the specialized variants, so you can see like YOLO version 5. It's a classic version, so very old version. So very stable but lightweight version. Or version 7, of course, excellent in speed and accuracy trade-off. And NAS also, like neural architecture search. Even CNN NAS is also there. And it's an optimized version. And YOLO World also, you can see for zero-shot object detection, you can use the YOLO World. Unseen objects also, you can try with YOLO World. And RT Detect, so Detect is the real-time Detect by Baidu has released it. It's a transform-based object detection model, an alternative to the YOLO version. And grounding Dino, this is the another version. So you can, it's actually a multimodal object detection approach. Along with the images, it accepts the text prompts also. So these are all the different versions of the YOLO and other variants. Along with the YOLO, this is also a very good model. You can try it out. And if you would like to work with multi-modal data, then you can go for the grounding Dino. Okay, yeah. So then when to use what kind of model? So you like where you can use it is like you can use it for medical imaging or like vehicle tracking or facial expression recognition or industrial defect detection. So if you would like to do it, you can train your own model, because YOLO is not meant for actually these kind of vehicle tracking or the medical imaging or facial expressions or for the industry defect detection, or like not for a specific work. Basically, it is trained on the COCO object data set, which is having the 80 different objects. And you can use this line of code for training your model, and then you can train it, you can pre-train, you can fine-tune you download your model, the YOLO model, and then fine-tune it on your data set, and then you can accomplish the job. So that is how you can use it. Then, so when to use what model? I hope by this time you must have got the idea. So if you have the CPU and real-time performance, you can go for YOLO 8 nano or YOLO 10 nano, you can try. And if it is a balanced accuracy, then you can go for YOLO 8S and YOLO version 9S, you can try. And for high precision research, like you can go for 8X or 9E. And if you are working with edge devices, then you have to go for YOLO 10N. And custom industrial, then you can try 8M with the fine tuning, you can try. So this is about the insights. And with this, I conclude the object detection part. I will be shifting to object tracking part. So where we are going to look at the tracking in the videos. So of course, object detection and tracking are two different tasks. They are not the same. So object detection is we are applying it on a single image, right? Whereas tracking, so we will be detecting like what is a video? Video is basically consecutive frames, right? Frames of images, you can say. And that is what the video is. And for every frame, we'll be applying the object detection, and then we'll be tracking the objects in consecutive frames or multiple frames, it is present or not, and that's what the tracking is. So object detection and tracking are two different tasks, but they're related tasks. And what the detection task does, and of course, when you are doing the tracking in the videos, then you have to apply the detection, and then a tracking algorithm you have to use. So like you can use YOLO for detection or BETA for detection or grounding, you can use. But for tracking, again, you have to use another algorithm. And detection, what it does is, it does the identification of the objects that are present, and it will be doing the bounding box, and the class labels also will be detected for every frame independently. Then we would like to do the tracking, means you have to, check consistently the objects are being detected in multiple frames or the consecutive frames or not. So maybe there is a person that is present, you would like to track that person. So the same person, or it could be a different person, or the same, like multiple persons in both frames or multiple frames. So over the time, you have to track them. So that is what, like, you have to use detection and the tracking algorithms. So let me quickly go through the demo. I think I may not be able to cover the theory and the demonstration. So I hope I better focus on the, and let me know how much time is left. So what is the closing time? Is it 9 or 9:30?
Hello.
Hello, sir.
9, madam.
9. Okay. Okay, sir.
9.
Yeah. Okay, sir. So we have only 10 minutes left. Okay. So let me show the demo quickly, how we can do this. So we'll be using, of course, the Ultralytics library, and we are importing, like you need to install all the libraries that are required. So along with the OpenCV, Matplotlib, and the Ultralytics. So you just import and then import the required libraries. Okay, install and import, that's it. So I have already discussed about this. So now we are going to upload a video here. So for uploading, like you can use a file sort upload, and then let me run this and show. So it's uploading because that's a video, it will take little time. So little percent done. So let's go ahead and see the remaining stuff. So now you are going, of course, you will be applying YOLO model only. So of course, I'm using YOLO P8N only because it's lightweight and very fast. And you create an object of that. And what we are going to do now, we are going to call the predict model on the video itself. Okay, so model.predict off, you have to pass rather than passing the image. Earlier we have passed the image and now we are going to pass the video. So that it will be tracking the objects. So by default, okay, here I have written, you can go through it and understand. So YOLO V8 internally, it will be using the byte track or the deep sort algorithms for the tracking purpose. So not only it will be detecting, in addition to that, it will be doing the tracking also. Okay, so there are two different algorithms that will be applied on this tracking. So when you pass a video, automatically YOLO does that. And the confidence you can set. So I would like to detect the objects for whose confidence value is greater than 0.4, greater than or equal to 0.4. And I would like to save the detected objects also. And where I would like to save it, I'm creating that folder. And my output should be saved in runs folder. And the name of the video also I'm giving, and then exist. Okay, yeah. This is done. No, it's only 17% done. Anyhow, let's run this and go back to the tracking algorithm. Let's try to understand how the tracking algorithm works. Meanwhile, it will be running. So I have shown you, right, like detection and tracking simultaneously it should be applied, and how it works. First, the detection algorithm is executed, like the YOLO algorithm is used for identifying the K, X, Y, that is the coordinates and width and height of the bounding box, and what is the confidence, what is the class ID. So all these will be detected by the YOLO. And along with that, we have to enable the tracking also. So we'll be combining the YOLO with the tracker, and that will be, taking care of the tracking. So the links between the detection and the detecting objects between consecutive frames that are available, the objects are found in every frame or not, it will be tracking. And for that, so you can use a deep sort algorithm. So with YOLO, you can use a deep sort or any other tracking algorithm also you can use. And what is this deep sort algorithm? It stands for SORT stands for simple online and real-time tracking with deep association matrix. So that is what the deep sort algorithm is. So simple online and real-time tracking. So it supports the real-time tracking of the objects that are being detected in frames of the video. So that is what the name is given as deep sort. So with deep association matrix. So that's where the deep sort is. So YOLO is applied. Along with that, deep sort is also applied. So that is what is happening in our demo actually. And the tracking process, how it does. So once the YOLO detects the bounding boxes, so deep sort will be using them, and it will be applying the Kalman filter to predict the next position of each of the object. So where it is present in the remaining frames. And then the Hungarian algorithm is used to match the detections across the frames, and how many frames it is detected. All these will be detected using this Hungarian algorithm. In the interest of time, I'm not able to go into the details of all these things. Then each object that is being identified will be given the ID. I have shown you, right, there are 80 different class IDs for the classes. So every object that is being detected will be given the ID. And the IDs will be maintained across the frames. And for every new frame, so this is for one frame. And then for every new frame, what it does, it compares the current detections with the next frame. And then it will be tracking those objects. And what it does for tracking, it will be computing the distance matrix. And the distance matrix will be based on the bounding box overlap. So the IOU value will be, compared, like intersection of unions. And then the visual appearance embedding also will be considered. And then the motion prediction. So all these will be computed. So that is why the deep sort is considered as the online and real-time tracking with deep association matrix. So the association matrix are computed. And then the Hungarian algorithm will be finding the best match between the old box and the new box. And if there is any new object that is being detected, then it will be giving a new ID. And if any old object is disappearing in the current frame, then the track will be lost. So of course it will be maintaining for few frames the tracking, but after that it will be losing it. So that is how the tracking algorithm works. And here the tracking algorithm, what we discussed is the deep sort as a tracking algorithm. And in addition to that, so you can try any of these tracking algorithms. So with OpenCV also supports KCF or CSRT or like MOSE or medium flow. Any of these tracking algorithms can be used along with the deep sort algorithm. And when to use what, you can go through it. Okay. And then summary of the tracking is, so YOLO along with the tracker you are using, and the workflow is like this. Like for a particular tth frame, so YOLO will be detecting the objects and deep sort will be assigning the IDs using motion and appearance. And in the next frame, YOLO again will be detecting the objects. And then deep sort will be matching the IDs with the previous IDs. It will be comparing. So that is how it will be drawing the bounding boxes and tracking the objects, maybe persons or any other objects also, like vehicles or whatever, will be tracking it. So that is how it works, the YOLO along with the tracking. Okay. Yeah. So now let's go ahead and see. It's too loading. It's too slow. So maybe meanwhile it is executing, I can take few of the questions if there are any. Hello?
Hello, madam.
Yes, sir.
Hello.
If there are any doubts for the participants?
Yes. If any participants have any question or doubt, so participant can ask our expert. So any participants have any questions?
Hello, ma'am.
Yeah, ma'am.
I'm Kimi Ramteke from Pune. So my question is, ma'am, as you mentioned the yellow, so can we use this yellow for like face related,
Yes,
if it is fake or not?
fake or not, it's not about classification. It is basically the detection model, man. So the object is present or not, you can identify. It's not for the classification purpose, basically.
Okay.
It's not a good idea to use for the fake image detection.
So some other
So,
model will be required in that place.
Yes, yes. Maybe if you can, what you can do in that case is you can consider it as a binary classification. You can have certain fake images in your data set. You can collect them, maybe AI generated images and certain normal images, original images. Okay. So all the original images you can name them as class 1, and the other images you can name them as a other class, like class 1, class 2. That is how you can name. You create your data set, and then like you can use any of the pre-trained models, and then fine tune it, and then you can complete it.
Okay. Thank you for this session.
Yeah, thank you. Yeah. Any other doubts? Okay, I assume there are no more doubts. I think the participants are tired. So if there are no other doubts, we will be closing the session. So it's still running anyhow. Yeah, because the video, it takes a long time. So now it is, yeah, thank you, Priya, right? So it's video, right? And now, right now, maybe the collab is also is fully loaded. So it is, yeah, here you can see. So it is loaded now. The video is uploaded. And now YOLO, we are you're calling, YOLO model on this video. And here you can observe one by one the frames you can see. So car is being detected. So for these frames, you observe, like first frame, car is being detected. Then there are 2 cars that are being detected. So can you observe? So for every frame, it is calling. So from the first frame onwards, there are totally 1200 frames in your video that we have uploaded. And frame 1, it is like frame 1 car, frame 2, 1 car, frame 3, 1 car. So that's how, like YOLO, however we applied, like that on every frame of the video, the YOLO will be applied. And then the tracking algorithm will be doing the matching between these two, whether they are related to the same object or different object. So that is what will be taken care by the tracking algorithm, the deep sort or any other algorithm that is used for the tracking will be taking care of that. And after this completion of the 1204 frames only, we can get that video, the bounding boxes. I'll show you that. That's still learning. It's only 450 frames that are done. You can see it's quick. It's quite fast, right? You can see like around 40 frames are done within 1 second. It's taking 244 microseconds for every frame. It's done. 550 frames are done. Yeah, thank you all for the positive comments on the session. Thank you. I am happy that you liked the session. And if it is helpful for your research, so I would be the happiest. And one more thing I would like to share in the meantime. So we are going to have one. So we are going to have a faculty development program on recent trends in artificial intelligence and deep learning. So from 10th to 14th November 2025. So you can see the speakers. These are the speakers are from premier institutions, and it is about the computer vision and the natural language processing. So it's a blend of advancements in both computer vision and natural language processing. So almost 20 different speakers are, so we have pulled for this session. So the experts are very good, like they have a lot of expertise in the fields. So all the premier institutions and the industry persons, industry professionals. And I will share you the link for registration. So please, I'll stop sharing for a second. And here is the registration link for registering this session. So you can register for this workshop if you are interested. Okay. Yeah, thank you, Swarup Nandi. So because we have curated the workshop such that it will give you all the details of, computer vision, a good blend of computer vision and natural language processing. Let me show you the result. I hope I will be able to. Yeah, please go through that link, and you can take my contact if it is needed from Gautam sir. If you have any doubts, either in the session or about the. Yeah, so now you can observe. So I hope my screen is visible to you. So like all the frames are being processed. Now I can show you. So content detect. YOLO video. This one. Just let me download it. Just wanted to show you the bounding boxes. I don't know how eager you are. I am eagerly waiting to show you that. So the video and all, they take long time. I should have saved the output. That would have been better, but anyhow, it's done. Yeah, can you see the objects are being detected? So when the same car is present in all the frames, you can see the same car it is showing, and the other cars. You observe, and this is a bus. The bus being tracked,
No,
and here you can observe.
It is not visible.
Oh,
Screen.
why, sir? Okay, I'm sorry. Let me share it again. I think I have shared only one window, so I'll share you screen again. So entire screen will be shared so that you can see. Yeah, I'll be playing the video again. Yeah, this is the detected after applying the object detection. So can you see the car is being detected with the confidence, and here the car, because it's very small and only frontal view, and here this car, and there is traffic light and the bus. The bus is moving, but still it is being able to, track, and there's a person, the person being detected, and he is out of focus, then the object being, so now can you see when the people are not in the focus, then they are left, their objects are being left. Yeah, this person. So that is what it is. So you can see from here. So here you can observe a person is coming. Yeah, person is being detected. So he's gone. So his identity is gone. So that is how it is being detected. Car is moving, and then it is still detecting. You observe? Yeah. So this is how it is. So I stop sharing the screen, and if you have any doubts on the session, on the topic, please feel free to contact me. Okay. Yeah, thank you, sir. Thank you for giving me the opportunity. Thank you, Gautam, sir. Yeah. And
thank you, madam.
yeah. So if they get back to you regarding the FDP or regarding the doubts, so please share with me. Thank you, sir. I'm leaving the session.
Okay, madam. Thank you.
Yeah.
So, dear participants, for today we conclude the session here. So again, we meet tomorrow at 6 p.m. Thank you.